Hi, I'm Yi-Lin Wu. I'm a lecturer in materials chemistry at Cardiff University. So being a faculty member, I will consider myself kind of lucky in the sense that I kind of fell in love into the light-matter interaction pretty early on in my career. Therefore, I spent some time to learn how to synthesize molecule and also learn some technique, especially the supramolecular chemistry, as a tool to organize molecules in 3 dimensions to control their intermolecular interactions. And in addition to this materials preparation part, I also spent a lot of time learning the spectroscopy stuff. This is in particularly during my postdoctoral research time. At Northwestern, I got involved into all sorts of time-resolved spectroscopy. And therefore, combining all this experience, we are very interested in developing new materials that are able to transform light energy into a high energy intermediate, and from there we can use them for chemical and physical processes. And we are particularly concentrated on the active species that is open shell in nature, like the triple excited state, like the radical species. Speaking of this triplet species, this is exactly the species that we were looking at in this chemical science publication. Yeah, in these materials, we were able to show that they display fairly bright phosphorescence. But to be honest, this work, the work that we publish in chemical science, has become very, very different from our initial anticipation. I mean, it's probably like all the other discovery that we have nowadays. It transformed a lot during the course of development. And initially, our thought was to take the material that we features in this paper as a building block for something else, really. Like we want to use that for singular fission. We want to use that for making polymers. But when we isolate those materials, we found that they display a very bright phosphorescence. And this is quite unusual for organic molecule because organic molecule, for one, they usually do not populate the triple excited state. For two, they usually do not emit light from the triplet state radiatively. Their excited state energy quenches very rapidly by thermal motion. So we noticed this unusual phenomena, and therefore we decided to take this huge excursion, really. And yeah, so that was the first twist in this project. And from there on, the initial study was done in some solution phase, as opposed to the crystalline solid that we really featured in this publication. And based on all this solution phase spectroscopy, based on the initial gas phase calculation, we kind of formed some idea as to why we observe this bright phosphorescence. But later on, we become more and more uncomfortable with this theory that we initially developed, because at the end of the day, if we think about the actual crystalline solid that we have, it is the crystalline solid being irradiated by light. It is the crystalline solid emitting the light. So why should we develop a theory based on monomeric isolated molecules? It doesn't sound very correct to us. And therefore, we decided maybe that's not the way to go. We need to invite a computational group to help us to model those solid state. And with their help, for one, we kind of completely ditched the original hypothesis, but more importantly, with their help, we were able to identify a very interesting fact in which we know that we show that the more halogen atom that we put on the molecule, even though they are technically heavy atoms, those heavy atoms do not necessarily contribute to a better intersystem crossing. They do not necessarily contribute to a better phosphorescence. So there seems to be a sweet spot that we got to hit. following this work, we also got to think about quite deeply why certain kind of things are more phosphorescent or luminescent in general. And this is part of our kind of a long-term goal for the future, really, because nowadays we have been thinking quite hard for a question, which is there a certain type of important vibration or crystalline photon mode that is mostly responsible for energy dissipation? As I said earlier, like a lot of time the excited state energy is quenched by thermal motion, and if we want to have a bright emission, we don't want to have that kind of motion. So if we can identify the key vibration mode that is killing the excited state, then we should be able to design our molecule better that avoids those kind of unwanted vibration. So that's one of the future directions that we are going after, and we think if we can really demonstrate that, that will be really, really good. And the other nice thing about this research is that you see it is kind of a serendipitous discovery, so to speak. But I got to shout out to all my coworkers. It is because with all together, we have the experience with this type of molecule, either from the synthetic aspect, either from the structural characterization aspect, either from the spectroscopy aspect. We know this type of material so well, such that even though the phenomena was not a planned research, once we identify something unusual, we can appreciate very quickly the importance of that. We can develop the most appropriate method to analyze that. So I think this is really the value of collaborated research. I'm also pretty glad that we got to publish this work in chemical science. I think this is just a correct platform. I mean, chemical science for me, it has the correct readership. I mean, people will come to chemical science trying to look for fundamental research. We don't necessarily need to demonstrate that the materials that we prepare has already hit the world best performance. It's not really the goal of our research, and it's probably also not the goal of chemical science. We just come here to disseminate our idea. And the other thing that I really like about chemical science is the fact that this is a society-run publication platform. So I can trust my manuscript is being handled by the fellow chemist. And not to mention, chemical science nowadays is an open access journal. I think this is brilliant. I think this should be a default in the future for any scientific publication. All the public all the reported research should be accessible by the public. Yeah.